Guys, hi, my name is Joanna. I'm the school programs manager here at the Cosmosphere, and I'm going to be doing our presentation today called Dr. Goddard's Lab. During this presentation, we're going to learn how rockets work, and we'll do so by somebody by the name of Dr. Robert Goddard. Now, first off, does anybody know who invented the world's first rocket? If you said China, you were correct. They invented gunpowder thousands and thousands of years ago. It was a very long time ago. And they did so because before there was chemistry, there was something called alchemy. And alchemists spent most of their time trying to take everyday metals kind of like this and turn them into valuable ones like gold because they wanted to be rich. And they also spent a lot of time looking for the elixir of life because they wanted to live forever. And so they were mixing stuff together to see what happened. And they happened to mix together potassium nitrate, charcoal, and sulfur. And I really hope they didn't try to eat the stuff, because I'm pretty sure if you ate gunpowder, you would live a shorter life than if not. Because when you mix these things together, this is what happens. So let's go ahead and see that in slow motion, just in case you missed it. And the Chinese, they used to stuff the gunpowder into bamboo tubes and throw it on the fire, and they would explode. So we have something like firecrackers. One day, one of the tubes contained the explosion. It shot into the sky, so we have something like fireworks. And they used to use these mainly for celebrations, like we use them for the 4th of July. Except that at this time, they were also having a problem with their neighbors called the Mongols. And there was nothing that they could do to defeat them. Until one day a village had a bunch of fireworks for a celebration, and somebody's like, why don't we try using these against the Mongols? So they go down to their local Walmart store, they buy some arrows and zip ties, and they attach their rockets to spears and arrows like this, and they fire them at the Mongols. Now, the Mongols had never seen an explosion before, and so they thought that the Chinese had acquired magical powers. And if you were to see something like I just showed you with the gunpowder for the first time in your life, I may think you've acquired magical powers too. There's this famous quote by science fiction author Arthur C. Clarke, who says that any sufficiently advanced technology can basically look like magic. And so that is what happened to the Mongols. So after that, China was at peace. They used that time to make advances in art, literature, and science. And during this time, there is the legend of Wan Hu. Now, Wan Hu is known as the world's first astronaut. And he was an aristocrat, which meant he had a lot of money. So he didn't have to work. So he had a lot of time on his hands. And he also had a lot of servants. And Wan Hu got it into his head that he was going to use the power of rockets to go to the moon, which he thought should be a pretty easy trip because he thought the moon was only about 25 miles away. So he strapped a bunch of fireworks to a chair, asked the servants to light him up, and what do you think happened to Wan Hu? Yeah, kaboom is correct. The legend goes that Wan Hu was never seen of again, but he was never forgotten. There's actually a Wan Hu crater on the moon that's named after him. And if you've ever seen the movie Kung Fu Panda before, Po straps a bunch of fireworks to his seat, much like Wan Hu. Now, I don't know what is the bigger honor, crater on the moon or Kung Fu Panda reference, because they're both pretty cool. Now, there's one thing that's really important when it comes to rocketry that Wan Hu didn't know about, and it's a pretty cool liquid. And I happen to have some right here. In fact, it's about 300 degrees below zero. And this is liquid oxygen. Now I'm going to pull out some so we can take a closer look. Now, it may be hard to see over the video, but I promise that I'm not lying to you. It is blue, like our sky. You'll notice that the fog is sinking, and that's because our atmosphere is made mostly of nitrogen, and oxygen is heavier. And if I place it down onto the countertop, because it is so cold, the coolness of the countertop is enough to make it boil, so it doesn't take a lot of heat. Now, everybody's favorite question is what happens if you touch it? Or some people like to ask, what would happen if you drink it? Now, I could stick my fingers in very quickly and pull them out, and it would be okay. But I'm not going to do that because if I leave them in there too long, let's use a balloon for my demonstration, and we'll see what happens. And it doesn't even take that long. Well, there we go. So we have to be very careful when we're handling our liquid oxygen. So let's see that in slow motion. So another thing that oxygen is good at, other than breaking off your fingers, is creating fire. So let's go ahead and start a fire. Now, I have oxygen in the air, but I need two other things to create a fire. What two things am I going to need? Okay, good. I will need a fuel. Good fuels include wood or gasoline. I'm going to use cotton because it burns very well. And then the third thing I will need is a heat source. Now I can't just stick this up on the light and it'll catch on fire. Maybe I could if I held it here long enough, but I'm going to use a lighter as my heat source. All right, so let's go ahead and start a fire. In 3, 2, and 1. All right, I know this isn't very exciting. So let's go a little bit bigger. Let's use this cotton ball. Let's use a blowtorch. And then let's add more oxygen to our fire. And it just so happens I have 100% oxygen right here. So let's give our cotton ball a little bath. Now I need to put on some protective equipment. And if you were here with me in the studio, I would joke about our blast shield. And that if you felt uncomfortable, you could use somebody you came with as a human shield. But since you guys are seeing this virtually, you guys are perfectly safe. All right, so let's go ahead and check in on our cotton ball. And that looks pretty good. Okay, hopefully bigger fireball in 3, 2, and 1. Okay, excellent. Now, just in case you missed that, let's see it in slow motion. It certainly looks magical. So somebody asked how my clothes don't catch on fire. Well, if you were much closer to me, you will notice I have several burn holes in my lab coat. So sometimes are more successful than others. But I wear the lab coat to protect my clothes. All right, so I know you guys can't see me right now, but it now looks like I have blown up a chicken. And so cotton and gunpowder are forms of a solid fuel. But let's talk about liquid fuels because, you know, we put liquid gasoline into our cars and it burns and makes our cars go. But I don't know about you, but when I was in school, my teacher told me liquids don't burn. So go ahead and tell me whether or not you think liquids burn in the chat. Okay, I'm getting a lot of yeses in chat, and that's fair. Also depends on what type of liquid. That's a good point. If we tried to catch water on fire, that would not work very well. So let's go ahead and start with liquid oxygen because I put a bunch of liquid oxygen on that cotton ball, and that cotton ball definitely burned up. But I'm going to tell you a little secret about oxygen. It's actually not flammable at all. It just makes things like cotton or this matchstick, things that are already flammable, be even more flammable. So if I'm lying to you and I light this match and stick it down to this oxygen, what will happen? All right, so if I'm lying, there's going to be a big bada boom. Hopefully I am not. Let's see what happens. So you'll notice it's not catching on fire, but when I bring my match closer, it starts burning brighter and hotter. And so it just makes things that are flammable even more flammable. And I could stick it down into the liquid for a little bit. And accidentally catch my cup on fire. It's a good thing there's not a smoke alarm in here. That just shows you how bad liquid oxygen is. I'm going to tell you a little story while I wait for this fire to go out. We used to take the liquid oxygen and pour it onto the floor in front of the thermal camera. And somebody dragged their shoe on the floor and there was a spark from static electricity and we caught the floor on fire. And so oxygen makes things extremely flammable. But I'm also going to tell you a secret. Liquids don't actually burn, and it does not depend on the liquid that it is, okay? It depends. No liquid burns. It's actually the invisible gas that we cannot see. So what I'm going to do is I am going to take this liquid fuel, pull it up through a nozzle. Okay, the nozzle is going to turn it into very small droplets. Those droplets are going to evaporate very quickly into the gas, and it will actually be the gas that catches on fire and not the liquid. All right, so let's go ahead and see that in slow motion just in case you missed it. All right, so if it is the gas that does the work, so to say, why do we put liquid in our cars? Because gasoline is a liquid. Well, fun fact, I'm gonna have to go get another cup. Hold on just a second. So gases take up a lot more room than their liquids. Okay. And so what I'm going to do is I'm going to take some of this liquid oxygen and I'm going to turn it into a gas. And I'm going to put the gas into a balloon. Okay, you'll notice my balloon is already full and I still have all of this liquid oxygen left over. And so we do not have enough carrying capacity in our cars and whatnot to carry our gasoline as a gas instead of a liquid. Okay. All right. So now we started off thousands of years ago with the invention of a solid fuel as gunpowder in our fireworks. And now we're going to move on to 1898 with a guy by the name of Robert Goddard being born. And when he was younger, he dreamed of sending people into space. Well, by the time he was a teenager, he had this idea. And his idea was for people to get inside a contraption and then spin them around and around and around and around and around and then fling them into space. Well, I don't know about you guys, but that does not seem like a very good idea. It may sound fun to some, but it makes my tummy very upset just thinking about it. Well, he got a little older, he got a little wiser, he got his PhD in physics, and then he began to focus on the rocket as the best way to put people into space. And when he told people what he wanted to do, they thought he was crazy. Because remember, this is the early 1900s. There aren't any cars and there aren't any airplanes. And here was Dr. Goddard going on about going to the moon and possibly to Mars, which we have not even done yet in 2020. So people started to call him names like Crazy Moon Man. But he didn't let that stand in his way. And in 1926, he launched the world's first rocket that used liquid for fuel. It went up about 41 feet high, fell to the side 180 feet, and it landed in his Aunt Effie's cabbage patch. And let me tell you, those cabbages burned straight to the ground. There were no survivors. And it turns out Dr. Goddard actually had a bit of a habit of burning things to the ground. He had already burnt his first laboratory to the ground. And so his neighbors figured by the time he was finished, he would have burnt their whole city to the ground. So they raised a fuss and the government ended up putting a ban on rockets except for the 4th of July. So if you're upset you can only play with fireworks on the 4th of July, you can blame people like Dr. Goddard because it's totally his fault. So he could not work in Massachusetts anymore, so he moved to Roswell, New Mexico. And let me tell you, there are only 2 things in Roswell, New Mexico. One of them is the desert, and the other thing is aliens, supposedly. And he did some of his best work there with rockets going as high as 9,000 feet, but nobody wanted to work with this crazy man, just a few people, including his wife. But he didn't let that stand in his way, and by the time it was all said and done, he had 214 patents in the field of rocketry. Many of those patents we still use in today's rockets. So I'm going to show you a video of today's rockets. It's the Dragon capsule that took the astronauts up to the International Space Station. It was the first time we launched Americans into space from American soil since 2011 with the space shuttle. And it turns out that building rockets is actually kind of hard. I guess that's why they call it rocket science. If one thing out of 1,000 goes wrong, then we will have a bad time. NASA had such a bad time in the early 50s and 60s that they had a 39% success rate, which means over 60% of their rockets were doing this on the launch pad. Now, we've actually gotten very good at building rockets. Our accidents have gone down significantly, but things still do happen. This is the Proton Rocket, which is a Russian rocket. Somebody installed the altimeter upside down, so the rocket thought it was going the wrong direction. So it turns around and then starts heading back toward the Earth. No, all of the rockets I have shown you, the first one contained a satellite, so no people, and the second one did not contain people either. There have been accidents where we have lost astronauts, but that was all during the shuttle era, and these were just, most of the accidents that happened did not contain any people. All right. So rockets use Newton's 3 laws of motion to work. The first one says that an object in motion will stay in motion. So that sun on top of the wheelchair kept moving in a straight line even though the wheelchair had stopped. And then objects at rest tend to stay at rest unless they're acted on by an outside force. Newton's second law is that the force is equal to the mass times the acceleration. So the smaller rocket on the left is the Falcon 9 that I showed you earlier. It's smaller and had produced less force than the Saturn V that we built in the 60s to take us to the moon. Until recently, the Saturn V was the most powerful rocket that ever existed. And just to give you some sort of idea about how much force it produced, it actually produces the same amount of energy as 36 Hoover dams. And then Newton's third law of motion says that for every action, there is an equal and opposite reaction, which is demonstrated by a fire hose. The water goes one way, and if you are small enough, you will go the other direction. Now, Dr. Goddard figured if it worked with water, it would work with fire. So he did some experiments, he did some research, and he ended up writing a paper called A Method of Reaching Extreme Altitudes. And the New York Times got a hold of it. And somebody at the New York Times thought they knew more about rockets or about physics than Dr. Goddard. You have to remember that rockets were still a thing of science fiction at this point. Traveling to the moon, there was no way they thought that would ever happen. And so the New York Times heavily criticized Dr. Goddard, saying that maybe he should go back to high school and relearn his physics. Rockets will never fly in space, they said, because there's no air up there for them to push against. Well, somebody ended up being right, and somebody ended up being wrong. Rockets do work in the vacuum of space. We have proven that over and over again over the last 50 years. And so let me go ahead and launch a rocket so we can see why that is the case. So don't get jealous of my rockets. I know it doesn't look like much, but it actually has the same parts as a real rocket. So here we have the combustion chamber. This is where the fuel and oxygen mix together. When the fuel becomes when the fuel becomes ignited, the atoms become very excited and they want to find the quickest way out, which is through the throat. The throat compresses the fire down and the fire exits the nozzle. So the fire goes that way, rocket goes that way. Now, left to its own devices, it would not go very straight. So I'm going to use a launch pad to keep it on track. Now, it's very important that I use the right amount of fuel. Okay, so hopefully good rocket blast. In 3, 2, and 1. That was a very good rocket blast. All right. And just in case you didn't see it, here it is in slow motion. You will notice that the rocket does not start moving until the gases hit the back of the rocket to move it forward. So the gases push against the rocket, and the rocket pushes against the gases. The rocket does not push against the air molecules. And so that is why rockets work in space, even though it is a vacuum. Now, unfortunately, Dr. Goddard died in 1945, which was about the same time America finally became interested in building their own rockets. So guess whose patent the government started to go through in order to build their rockets? If you're thinking Dr. Goddard, you are correct. Now, his wife was still alive at the time, and she liked to watch the rocket launches on TV because, you know, 61% of the time they would blow up, and it was very exciting. And so she had worked very closely with her husband over the years, and she started to notice things that she knew her husband had invented. And so she got a hold of the government and went, hey, you didn't ask me if you could use my husband's stuff, and you're definitely not paying me for it. And the government was still the government in the 40s and said, we're not going to pay you. So she sued, and she lost the first time. So she sued again, and she lost the second time. But third time's the charm. She ended up winning $1 million in order for the government to use her husband's patents, which is a lot of money now. That was a lot of money back then. And she actually used that money, and she split it up among the few people who had helped out her husband back in the day, which was a very nice thing to do. So there's a lot we can learn from Dr. Goddard. He never gave up when he got run out of his home state. He didn't give up when people started to call him names. He didn't give up when nobody wanted to work with him. And I don't know about you, but if the New York Times called me stupid, I may be rethinking my life choices. But none of that stopped him. And fun fact, in 1969, when we finally launched the world's first rocket, sorry, let me backtrack. 1969, when we finally went to the moon, the New York Times offered Dr. Goddard an official apology saying, you know, they were wrong and he was right all along. Now, it's about 20 years after he died, but I guess it's the thought that counts. And now Dr. Goddard is known as the father of modern rocketry, and without him, we wouldn't be able to go back to the moon or go on to Mars. So if there is something you're passionate about and willing to work hard for, make sure you don't give up on your dreams. You could be the next Dr. Robert Goddard. That's going to conclude our show for today. I want to thank you guys. You're a great audience. Do you have any other questions before we go? Okay, so I got a question about what rocket is bigger than the Saturn V. So there's the Sls Rocket, which stands for Space Launch System. It is the new rocket that NASA is going to use to go back to the moon in 2024 and go to Mars sometime in the future. And it puts out more force than it's bigger than the Saturn V. But that is the only rocket that's beaten it so far. It's held that rocket record since the 60s. What would happen if I put too much fuel? Okay, well, I can do that. It will not. So remember, we need oxygen for a good fire. And so if I put in too much fuel, there is not enough oxygen to light the fire. And so this is what happens. Nothing very exciting. So you know in movies when somebody clips a gas tank and the room fills up with gas, and then there's a huge explosion. Once there's more gas than oxygen, nothing would happen because there wouldn't be any oxygen for the fire. Yes, the gas displaces the oxygen in the room or in the rocket. That was a great question. Anything else? Inside real rockets versus this one, they have a fuel, usually hydrogen, liquid hydrogen, and they have an oxidizer. Oxidizer is just a fancy word for oxygen. So they're in separate tanks, but they'll flow together and come, it literally is like a nozzle on a spray bottle. And so they'll come together, they'll spray the fuel, and then there's a spark, and that will catch the fire, catch it on fire. There's this thing called hypergolic fuels, and if you mix those together, they start without any spark, but they're highly dangerous and cancer-causing. So we don't usually use them anymore when there's people involved. Yes, the only difference between a missile and a rocket is its payload. So missiles contain warheads and rockets contain people. Other than that, they're pretty much the same thing. Thank you so much for joining me, and I hope you guys have a wonderful day.